Okay, we are continuing on. This was our day 2 chords. So we talked about different types of angles. Now we're going to different types of segments. So in this picture, it's called the tangent-tangent theorem. Two tangent segments are congruent or equal. So this segment line is equal or congruent to that segment line. So it's called tangent equals tangent. The chords are separated by parts of each chord. So if I did, this is like chord 1, and this is chord 2. The parts of these chords, so I'll like highlight this as chord 1. So the part of that chord would be like A times B. And compare that to this chord, which would be equal to C times D. So that is called the chord-chord theorem. It's the part times the part of one chord equals the part times the part of a second chord. So we're going to apply those two theorems on your next page. We're going to apply this one first to perimeter. These lines are all on the exterior, so this is called the tangent-tangent theorem. Because these are tangent lines. So if these, from this given point out here, are the same distance to the circle, if that line 16, this line 16. Same thing if from this point to this point should be the same distance. So if this is 9.5, that's 9.5. And the last one, we'll highlight in a different color. From D to the circle and D to the circle, it should be the same distance. So this distance is 11. To find perimeter, you just add up all those numbers that go around the circle. So if we add up all 11, 16, 9.5, so one big addition. Perimeter adding up all the sides. So the total length was 73. The next one, these are called chords. So this is called the chord theorem. On day 1, we learned a chord is a segment inside of a circle. So just like we did on what is a chord theorem, we highlighted them with two different colors to represent the two different chords. So chord 1 would be like 10 times x, or just 10x. That should be equal to chord number 2, which is 14 times 15. And it doesn't matter which order you multiply numbers in, but 10 times x is just 10x, and 14 times 15 is 210. So that was the part times the part. To solve, you divide both sides by the number with the x. So we'll divide by 10, and we get x equals 21. Put that up on the line. X equals 21. So it's a tangent, and a chord example. So looking at the next one, this is an again example. The segments are on the outside, so this is called tangent. And if you just want to abbreviate, that's fine too. So the tangent says these two tangents are equal to each other. So 43 minus 2x is equal to 12x plus 1. And then once you've set them equal, you solve by getting your x's on the same side. So let's add the 2x to this side. That will give me 43 equals 14x plus 1. Then let's take the numbers to the other side. So I will subtract the 1 over here, get 42. Equals 14x. We'll divide by the 14 to get x by itself. So x equals 3. So I'll put that on the line. This one asks us to go one step further though. This one says we want to find yx. So in this picture, yx is this one. So we want to plug it into that. So 12 times 3 plus 1. So yx equals, that's 36, so 37. So once you find x, you just had to plug it back in. This is just like the one above it. This is called chord. So one chord, if I multiply these two things together, it would look like 4 times 5x minus 1. If you ever have a plus and a minus, you want to make sure that you put it in parentheses. And the other direction, I would say the other chord would be the 6 times 6. So you can either write 6 times 6, or if you just want to go ahead and multiply that in your head, 6 times 6 gives us 36. Okay, this one is a little bit harder than the last one because we don't just have one step to do. We have to distribute 4 times the 5x and 4 times the negative 1. So we get 20x minus 4 equals 36. Going to add the 4 to the other side to get x by itself. So we have 20x equals 40. Now we'll divide both sides by 20. So 40 divided by 20 would be 2. So this one wants us to plug it back in to find dB. So dB is the whole length of that. So if you plug it in here, 5 times 2 minus 1, this part equals 9. But it wants to know the whole length from D to B. So we would add these two numbers together to say dB is going to equal 13. So 9 here plus the 4 there gives us a total length of 13 for dB. Alright, so those are the two examples of tangent, and chord. The last thing we have is what's called a radius tangent theorem. In this picture, this is called the radius, and this is called a tangent. So this theorem says the angle formed by a tangent and a radius is 90 degrees. So they use this often in pictures that look like this one to the right. Find the length of from A to C, all the way there. Because this is a radius, and this is a radius, and this is a tangent line, they form 90 degrees at the corner. And previously this year, we learned how to find the diagonal in a right triangle. We used Pythagorean theorem. A squared plus b squared equals c squared. And don't get hung up on the letters. Remember, that just means the leg squared plus the leg squared equals the hypotenuse squared. Okay, so in this picture, our legs are 5 and 8. And we're looking for the hypotenuse. So we'll just call it x squared. If you square this, you get 25 plus 64. We add those together, you get 89 equals x squared. So So maybe you remember, to get x by itself, we have to square root 89, and we're just going to round it to the nearest tenth. So x would equal about 9.4. So if you ever see this, a radius and a tangent, they form a 90-degree corner, and to solve, we would use Pythagorean theorem to find a missing side, whether we need to find the radius, the tangent, or this hypotenuse line.